Good evening and welcome back. So in this video we're going to finally add some blueprints to our player blueprint. So if we go back to our BP player, in the previous video we just created everything ready for when we start doing this. We have all of the variables ready. We have the ship set up so we can actually see something and it exists. And we have our input set up, so when we start adding the movement, that's ready too. Now what we're going to do is we're going to start by spawning this into the world. And when we spawn this in, what I have planned is we're going to have a nice little animation which will make it spin and then float up the screen so it's in point ready to take control. Just looks a little bit more interesting than having it just start flat still on the screen. So inside of the event graph, I'm going to remove these for now. We don't need those right at the moment. And we can drag straight off of the begin play. And what we want to do first of all is we have our reference down there to the BP game mode. So we're going to do something called casting. We're going to cast to BP_game mode. So that is trying to find a blueprint object of the type game mode. If it can find one, then we get two return values, that it's either successfully found it, which would be off of this node, or that the cast failed, which means it doesn't currently exist. Which would indicate that we have a problem because we have told our project that it's using the BP_game mode. So if it doesn't have that, it means it doesn't have a driving manager for this game, which all Unreal projects will need a game mode, and it should be the one that you've assigned to it. So this is why we're doing this here. And to get this to work, all we need to do is drag off of the object. So this is going to be the argument, what it's looking for, and we'll type get game mode. So again, this is simply going to say what's the current game mode, which will essentially direct it here. It will find that we've told it that BP_game mode should be the game mode. It will then check, is this BP_game mode, which it is, which means we should always get this as a success returned here. And when that happens, what we want to do is we will set the BP_game mode reference we've created. So I'm going to alt drag this in, which will give us a set value, and we'll just connect these up. So that means we've now found what the game mode is, and we've stored a reference of it here so that we can use it a bit later. And if you don't understand what the getting and setting of references means, this is something that could take quite a while to explain, but as we start using it, and we will be using it more than once in this project as well, it's going to start making more and more sense. So I tend to take the approach of kind of learning as you do, and we will see this in a very practical use, and it will begin to make a lot more sense. So I don't want to spend too much time explaining it ahead of time. So the next thing we want to do is we need to also set our yaw value. So the yaw is just simply the rotational yaw of the ship when it starts the game. So to get that, we will alt drag the yaw value. We'll connect that up straight away. And what this will be, if we drag off of here, and we will find a break rotator. So this is just simply breaking the rotation of an object that we give it, and we want not the roll, we want the yaw, which is the z-axis. So if we go in here quickly, in fact that won't work here. If I just drag this in, if we press E to rotate, and we want the blue part of the rotation widget here, and we can see the color blue lines up with the z-axis. So we've got X, Y, Z, and that will be the yaw that we're rotating there. So this is going to be how we spin the player in, which is why we want the yaw value. So I just delete that, and again, this will all start making more sense as it becomes functional. But for now, we're going to drag off the break rotator, and we will type get actor rotation. And this is simply going to return the rotation of the actor when it begins play, which to be honest is going to be 0, 0, 0, and we know that for a fact because we're going to be setting it up to be that way. But just again, in case something weird happens, this will help to nullify that problem if we just simply store a reference of that now. So when this queries this will just return 0 for the yaw, and it will store our personally created yaw value as 0 as well. And finally, we're going to do one more setting of a variable. So we'll alt drag the spawn location in. We will drag that execution node over there. And this is just as simple, if not simpler actually. We're going to drag off of the argument pin and say get actor location. Okay, so this is simply finding out where in the world the actor is, and the actor is this blueprint in its entirety, and it's setting that as the spawn location. And we'll be using all of this in an argument in just a moment in the animation. So the next thing we want to create is if we right click and type in add timeline, we should only get one option, which is to add this timeline here. And I'm just going to press F2 to rename this, and we'll call this the spawn animation. So as soon as we have all of our values set, and these are all ready to use later when we need these references, we can play the spawn animation, because the game is now ready to go. Now, if we double click this node, the spawn animation node, we get access to the timeline, which is essentially going to be a graph where we can add different curves and interesting variables to control the speed that something moves. Or at least that's what it's going to be used for in this instance. So if we set that up first of all, the first thing we want is the length to be changed. We don't want the full animation to take 5 seconds, because imagine waiting for your player to spawn for 5 seconds every time you died. That's going to become quite annoying. So we're going to turn this down to 1 second. The next thing is we're going to add a float graph by just adding float here, and we'll call this the speed. So this is just going to be the speed that the player rotates. And quite simply, we're going to right click on the graph and we'll add 2 key points. So do that twice. If we drag select the first one, and we'll set the time to be 0, and then tab to move over to the value, and we'll make sure that the value is dead on 0 as well. And then drag select the second one, and we'll set that time to be 1, so the end of the graph, and we'll set the value to be 1. So we're just going from a 0 to 1 value, which will be a multiplication that we'll be using in a moment. And then if we drag select both of these, just right click on those and click auto, and that'll make a slight curve for us. And then I just like to move the bottom one up here. So if we drag that arm and move that up, we're going to get a nice smoother curve when we run the animation. And you can play about with these values to see what they do, and we'll do that in just a moment, in fact. Okay, so to leave the timeline, we're going to go back into the event graph. We can see that we now have a new node down here called speed, which is the value that we've just made this float track here. So this is going to be updated for 1 second, and we'll use that value to run the animation of the rotation and where the player is in the world as well. And to do this, whilst this is running, so this will be updating for the 1 second. So as this updates, we want to set actor location. So search set actor location, and this will simply update the value, which we're going to use here, our spawn location, and we're going to add an offset to that to set where the blueprint is in the world. So if we control drag this time, the spawn location, so we're going to get the value this time, so we can see the difference of the nodes here. This is a setting node and this is a getting node. So this will store a value in here, which we can see at the moment defaults to 0, 0, 0. And when we run this, this is going to get a different value for us, and it will plug that into spawn location. So it will change that from 0, 0, 0. We're then going to get that location later, which is what this will return. And we will use that in a calculation here. But just before I do that, actually, why don't I demonstrate that? So we'll do this twice. If we pull off of here and we'll type print string, and what we'll do first of all is we will plug in our spawn location to print to the screen what it is before we set this, before we update this value. And then we're going to do the same thing a second time, so print string, and just get another version of that to keep things tidy, and we'll move that over here and we'll plug that in. So we'll see what the value is. The first time it prints this, it should be 0, 0, 0, because that's what we've set it to be, or it's what it defaults to be. And then the second time it runs this, it should be whatever the location in the world is. So if we go back to main, we'll drag this in, and what I would expect it to print is 0, 0, 0, and then minus 470, minus 590, and minus 240, because that's the value that this will be getting, and then it will plug that in here, and then we'll be getting it and printing it out. So, okay, that was not staying on screen for long enough. So if we just go back in here, change that to 10 seconds, and 10 seconds, press play. So we can see in reverse order, the first one it printed was 0, 0, 0, and then the second one is minus 470, and so on, like I said it would be. So hopefully that makes a bit more sense on what that's doing, how we're getting a value from this one and we're setting it in this one. So I'm just going to plug those back up. We do not need those print strings. Okay, so with our spawn location though, what we want to do is we want to get the value which is in this, and we want to do something called lerping. So this is a linear interpolation between two values, essentially just a smoothing between A and B, or yeah, between A and B as you can see here. And what we're going to do is we will take our spawn location and then say plus a vector, so vector plus vector, and we'll plug that into the B argument. And essentially all this is doing is it is lerping, so again moving smoothly between A, which is where we start, and B, which is where we start, plus an offset which will make 60 on the z-axis. So Z is going up the screen, so it's going to be where we start plus 60 units upwards on the screen. And that's just going to be our simple movement. That will be driven based on speed, so over time, and that, when that calculation is being updated, will be the location we want to set the actor. And again, remember the actor is the blueprint in its entirety. So the player mesh, the projectile spawn, and the particle system will all be moved up the screen 60 units. So I think that's nice and simple. And then off of the location, whilst this is being updated, we want to set actor rotation. So this is going to be our little spin that I mentioned. And really this is very much the same logic. So we will drag off of the new rotation. We want to lerp rotator this time. So very similar to the lerp vector, but this is specifically created as a kind of boilerplate blueprint by Epic to manage a slight difference between how rotation is slightly different to vector math. And we want to go from 0, 0, 0 because, as I said, we know that our player ship is going to start at a 0, 0, 0 rotation. And we want to lerp that to a new rotation. So we're going to drag off of the B argument and make rotator. And remember, to get that spinning motion, all we're doing is when we go in, we are going to be rotating around the z-axis. And notice that as I do this, the x and the y aren't changing, we're just changing the z, which means that all we are concerned of in here as well is the Yule rotation. And remember that we've stored a Yule rotation already, so we're going to control drag our Yule value. We will add a float to a float, so float plus float, and we will pass that in to our rotation that we're making. Just move that to tidy that up. And I find that a value of 720 works quite nicely. So this is going to just flip twice as it's moving upwards. And again, the alpha value that we have here, so the speed that this happens, is going to be based on our timeline that we created. So if we just drag that back up to the speed as well, and try and keep this as tidy as we can, but it does get to a stage where you have wires everywhere, unfortunately. Okay, so now that should be ready to go for the spawn animation at least. And one final thing that we want to do, and this has caused a lot of people a lot of problems in the past, do not forget to do this. We will alt drag the move enabled in, and we will, when this is finished, make sure to drag off of the finished into the setting of the Boolean and tick that move is enabled. So this now allows us to move the player. When we set the input up, this will unlock the player for us essentially. If you don't do that, you won't be able to move the player when we do our logic implementation in later videos, so keep that in mind. So if I just quickly go back to the main window, and in fact if we just zero this out to make sure that everything's normal, just pressing F to focus in on the ship, move back a bit so we can see what happens. We'll just hit play, and there we go. We can see he has a nice little spin and moves up the screen slightly, so I think that's pretty pleasant. And you can play about with the values here. We can come down here and we can double this, so we make this 1440, and we can just see how many extra spins that he will do. There we go. That actually looks pretty cool. I'm going to leave it as that. And we can also change things like the distance that we move. And another useful thing here, in fact, before I close this one off, is if we drag off of this value that we've just updated and select promote to variable, we'll just call this the spawn spin count. This is how you can just quickly upgrade a variable to be a named variable rather than a magic value. So essentially a value that when you look back through this, you may not remember what it was controlling because it's just a number. Whereas at least if we come back to our code in a few months' time, we can look through this and we can get a general idea of what's happening, and then we'll look down here and go, oh, what was that? And we may not know. But when we look at this, we now know this is literally controlling the number of times that the player ship spins while spawning. So it just makes a bit more sense if we add text to as many variables as we can, really. You could break this down and do that here as well. So I'm going to leave that just for cleanliness, really. But this one was just a nice way to show how we can promote something which isn't a variable, or it isn't a stored variable, to be a variable that we keep track of. And we can also see that the other good thing about doing it this way is that it still has the 1440 that I entered into it. So if you've entered a value into a text field like this, and then you promote it to a variable, it keeps the value that was in there before you promoted it. So that's pretty handy as well. And just to prove that nothing else changes, we'll just go back out, press play, and it still does its nice spinning animation. So that is the player spawn animation done. Final thing to tidy this up is we'll just drag everything and press C around once we've dragged around everything. So C is to add a comment, and we'll just, again, remind ourselves, or future selves, that this is the player spawn animation. Nice and simple. So again, when we come back, we know what we've implemented. Okay, so I'll leave that there for the player blueprint for now. As always though, if you've enjoyed the content or find it useful, then please do leave a like and give the video a share. That always helps. If you'd like to be kept up to date with the latest content, then do feel free to subscribe to the channel. Alternatively, you can follow me on Twitter. Links for that will be in the description below. And now, if you'd like to show your support for the channel, you can check out the Patreon page. As ever though, thanks for watching, and I'll see you next time.